Hey everyone, sorry I couldn't be in class today. I would love to have had a Google Meet, but I have a practice round with my golf team today for regions. So what I'm going to do instead is I'm going to go over all of the odds from the homework from last night, or from the last time I've seen you. And then what you will do is you will turn in photos of your completed odds and evens. So in essence, I'm doing half the problems with you. You can do the other half on your own and just submit it in Google Classroom. All right, so here we go. So number one, let me read the directions. So we're going to graph both the parent function and the transform function. We're going to state the domain and range of the transform function. So, and on your sheet, you make a note. I have some stuff laid out here in the margins to kind of lead you along. So I'll kind of write that as I go. So the first thing I see when I look at this function in number one is I see, well, that parent is definitely an absolute value. So let's start there. So the parent function is absolute value. So let's go ahead and graph the parent. So the parent's absolute value, you have it in your notes. And this is what the absolute value parent looks like. It's the V-shaped graph. You can plot as many points as you need. I'm just going to plot those 5. So there's my parent function. Now let's look at the transformation. So the first thing I see that's different for transformations is I see this negative here. So that negative, if you look at your transformation guide, means there's going to be a reflection over the x-axis. So my first transformation is a reflection over the x-axis. So all of these points in red, those 5 points plus the arrows, are going to flip upside down. But we got more transformations. The next thing I see is this +2. And again, if you look at your transformation guide, that's H on your transformation cheat sheet. That means we're going to go left 2. So each of these points is going to have a horizontal translation. I'm going to abbreviate left 2. And then the third transformation I see is this +4. That means it's a vertical translation. Up 4. So let's go ahead and graph this. So I'll graph it in blue, just like my transform. So I'm going to do it in order. So in the order I read them is how I'm going to shift these. So this point here at it's up at 2. It's going to reflect to -2. So it's going to reflect down here. And then I got to move that little x to the left 2 and up 4. So I go 1, 2 to the left, 1, 2, 3, 4 up. So there's my new point. Erase all these x's. And then I go to my next point. So this point up at 1 is going to reflect to -1. And then I got to shift it left 2. So 1, 2. To here, and then up 4. 1, 2, 3, 4. That point's now there. And let me go to the next point. It says point at 0. I can't really reflect it if it's on the x-axis. So now I just shift it. So left 2. Let me erase that. So I'm going to go left 2. 1, 2. Up 4, 1, 2, 3, 4. There it is. I'm going to keep doing that. So this point up at 1 reflects to -1. And I go left 2, and then up 1, 2, 3, 4. Same thing, this last point that's up at 2 is going to reflect to -2, but then I got to shift it. Left 2, up 1, 2, 3, 4. And that's enough points that I can get a sketch in of that new absolute value function. So that's my new absolute value, and the last thing I asked for is domain and range. So here, domain, how far left to how far right? Well, that arrow, this blue arrow, is telling me it's going left forever, so that's -infinity. This right arrow is telling me it's right forever, so that's +infinity. And then for the range, Both those arrows are pointing down, so that means the lowest y is negative infinity. And the highest y value I have is right here at that peak of the v. And that looks like it's at 4. It's tough for me to see here, but it looks like negative infinity to 4 is my range. All right, here's number 3. Number 3, if I look at it, I can see the parent function is going to be a quadratic. Okay, this is telling me the parent function is quadratic. I don't have as much space on here. And then the quadratic parent from my notes, or from your notes, looks like this. I'm just literally taking the points that I plotted in my notes. Shoot. I'm literally taking the points that I plotted in my notes and just plotting them on this graph. You have your notes for now. 2, 3. So here is my U-shaped parent. But I don't have the parent. Here I have transformation. So the first thing I see is this 2. So that's going to be a vertical stretch by 2. Meaning every point's going to get twice as tall. And then I have a plus 3 in parentheses. So that means this is going to be a horizontal translation to the left 3. So after I reflect those points, I'm going to shift them left 3. And I see this plus 4 on the end. That's a vertical translation up. Up 4. So that's what I'm going to do to each one of those points on my parent, if I can. Excuse me. Notice this first point, it has a height of 9. So it's up here at 9. If I stretch it, it goes way off my screen. So we're just going to forget that point for now. We're just going to leave it where it is. Now we're going to the next point. And my next point that I can stretch is right here at a height of 4. So if this point, this blue X, starts at 4 and I double its height, it's going to double to 8. It's going to double up there. I'm pulling it up. And then I'm going to shift that to the left 3. 1, 2, 3. And up 4. 1, 2, 3, 4. Let me go back here and erase these. I don't need my graph, but I'll sketch it back in. I just need those points. Sketch it back in. All right, I'm going to go to my next point. My next point's down here at 1. Height of 1, if I double its height, I go to a height of 2. And then I'm going to go left 3. So left, 1, 2, 3, and up 4. 1, 2, 3, 4. So there's my dew point. It was right here. And then my origin, the point at the origin, I can't really stretch it. That's right here, but I can shift it. Left 3, 1, 2, 3, up 4. 1, 2, 3, 4. And then you can kind of use symmetry from here, but this point at 2, if I stretch it, it stretches up to, sorry, it's up at 4. If I stretch it, it's up to 8 right here, and then I got to shift it. Oh, I skipped a point. That's why I'm messed up here. Hold on. All right, this point at 1, I skipped this guy. So this point at 1, I stretch it, it goes up to 2 right here. But then I got to go left 3, 1, 2, 3, up 4, 1, 2, 3, 4. And then this point now that's at 4, it stretches up here to 8. And then I go left 3, 1, 2, 3, up 4, 1, 2, 3, 4. And here is my transform function. And last thing real quick, domain here. I have a left arrow and a right arrow. So that domain is negative infinity to infinity. The range, the lowest point on this graph is right here at, looks like 4. It's tough for me to see. I think it's 4. And that's going to be a bracket. So the range is going to go from 4, and the arrow's pointing up means it goes to infinity. All right, this is the last one I'm going to be able to fit on this video. Y equals 2 square root of x, so the parent function there is square root. And I'm going to graph the parent in red. Again, you have these in your notes. I gotta look at my thing. Oh, sorry, that only goes to 8. Those are only 3 points I can fit on here. And the only transformation is a vertical stretch by 2. A factor of 2. So what that means is all those points are going to get twice as tall, and that's it. So if I start on the origin, I can't really stretch off the origin, so that point stays. This point that has a height of 1 is going to stretch to a double height at 2. And this point at 4, 2, its height is at 2, but it's going to stretch up here to 4 because it's twice as tall. So this is my new transform function. Domain, this function, its furthest left point is at 0 right here. So it starts at 0 and it goes right forever to infinity. And the range, the lowest point, is also 0. And it's going to go up forever to infinity.